And this moonshot goal is to create a fully climate neutral EV by 2030.
It's pretty soon, excuse me, but that's soon.
You need to have that sense of urgency when it comes to sustainability, taking the responsibility of addressing the emissions that come from the production of a car across the entire life cycle, from sourcing materials to the end of life.
Hello and welcome to this special episode of the Goldcasting Podcast. Today we have a very special guest. We would welcome Marco Carlson from Polestar today in our podcast. Welcome, Marco.
Hi, thank you for the warm welcome, Fabian and Staffan.
Pleasure is ours. First, something very interesting. Could you tell us a little bit more about yourself? I mean, you're an academic overachiever, maybe, or a superstar in the academic world, and now you have transformed into the cruel world of automotive. So we're pretty curious. Who is Marco Carlson?
Starting from right now, I am serving as a TPL or technical project leader in metals and minerals at Polestar. And my background includes around 15 years of research and industry experience in material science and with the focus on sustainable solutions for metals production and certain aspects of manufacturing. I could also add that prior to Polestar, I was working with Volvo Group. And prior to that, I had the pleasure of collaborating with some of the most brilliant researchers from around the world, Sweden, UK, Australia, and the US, on various topics surrounding metals and minerals. Apart from the technical background, I am a father of two and will soon become an owner of Polestar 4.
Oh.
You used that commercial break to put it in.
Yeah. That's great. That's great.
Yeah. But I can imagine. I've seen the car. That looks good.
But you see number 5 without the windscreen in the back. It's just the camera. It's so super cool.
That's actually number 4.
That's 4. Oh, sorry.
Yeah, exactly.
But you were ranked among the 2% most valuable researchers. Was it at Stanford somewhere? And you choose to go to Polestar. I really need to dig into this. I mean, I'm kind of guessing you could choose a bunch of interesting things from San Francisco to Tokyo, and you end up with Polestar. And I guess that has something to do with the Polestar profile. But could you elaborate a little bit about that?
Moving from academia to industry was definitely a shift for me. And as you can imagine, and you are aware that in academia, one has to spend a lot of time, years and years, to learn the fundamentals of engineering and science and be in the lab. In my case, I was in front of microscopes couple of thousands of hours when I was in academia, dealing with research papers, writing, applying for grants, etc. But I would say now, instead of doing that, instead of trying to impress reviewers of the research papers or winning research grants, I am applying that knowledge into real-world solutions like sustainable cars and electric vehicles. This is the area I admire a lot when it comes to EVs, and at the same time to emphasize on the sustainability aspects. But both are challenging yet rewarding, I would say, very rewarding.
But I need to follow up a little bit on that, because at Comtech we pride ourselves having a quite sustainable solution. I mean, it's not perfect, it's not 100%, but it's a good step on the way. And we thought that, this is the great sales thing, we can pitch this around the world. We will have a queue in Skillingaryd for people wanting to buy this, at least for the sake of the C-band that's coming up. But so far, the number of companies working sustainable castings with us are this many. You got the Polestar, you got the Ericsson, you have the Getinge Maquet, and then some other firms. But these are the top guys that really focus on this. And how could it be so ignorant out there in automotive that the only guys that I feel is really serious is Polestar?
One could highlight the 17 SDGs, the goals for sustainable development, starting from no poverty to partnership for achieving the goals. And number 13 is the climate action. And when you read about it, it says very clearly that there is an urgent need to act in order to combat climate crisis and climate change. And this will affect everyone in every country. I mean, at the first step, one needs to understand and digest this fact, how important it is in society, every person, every company, every government. But it seems that during the past few years, there has been a lot of things happening for the society, COVID, and then some financial issues that the companies are facing. And still, the one reason that I'm proud to be part of Polestar is that we did our best to stick to our values, how we could act, what kind of urgent and effective action we could take. So I would say there are a lot of different things from finance, from societal effects are affecting sustainability. But I would see that the future is going to be different as people and the public will understand that. I think this is what they need to ask for, even though there are not enough and effective policies in place. But this will be a demand from the public.
You must have a certain kind of people at Polestar. Let me elaborate a little bit, because we have podcast episodes about how important it is to have great people from the board of directors all down the way, to guy cleaning the floor. And it seems that in Polestar, everybody is sharing this way of thinking. Am I right here, or is it just in my head that I feel that people are actually more aware about sustainability and working towards these goals?
Exactly. That's I would say it's definitely the case. My own personal experience as well. At Polestar, I would say performance, design, innovation, and sustainability are at the heart of anything being done. We have a great, very knowledgeable sustainability team who are working closely with different departments and, of course, with the set of very skilled automotive engineers. I would say there has been a lot of successes on that front. For example, we have a manufacturing facility which is powered 100% by renewable electricity, renewable energy sources. And that would mean 500 kilogram CO2e reduction per electric vehicle. I can give you another one, like Polestar 2 now. 85% of this car, very complex premium car, you could almost find every element in the periodic table in an electric car today. 85% of this vehicle is recyclable, with components to being reused or remanufactured. So a lot of things happening on that front. And apart from that, we have Polestar Zero Project, which is very different type of engineering car program that I can explain further if you are interested.
Yeah, definitely. Please go ahead. And especially with the sustainability, there are always two routes to take. The one route that many people go is, okay, we have a slide that has a green background, and we have suggested that would be our carbon footprint, and we bought some wood somewhere in Eastern Europe or in Asia, and that is our offset, and now we are neutral and can have a second green slide. Or like you do it with the Project Zero, and really start from the ground up to get to zero. And definitely we want to have the explanation.
Polestar Zero Project is an even more intensive project towards the climate action that has been outlined by UN. And it has a moonshot goal, as we call. And this moonshot goal is to create a fully climate neutral EV by 2030.
It's pretty soon, excuse me, but that's soon. In car industry, that's tomorrow. Please continue. I just needed to make that remark.
No, that's definitely the case. So one needs to really to analyze what urgent means. And rather than just pushing the deadlines to 2040, 50, etc., but you need to have that sense of urgency when it comes to sustainability. Otherwise, nothing will happen. When we talk about this Polestar Zero project, one could say that, but you do not have any tailpipe emissions. It's an electric vehicle, and the electricity could come from renewable sources. And this is something that has to be planned by the government. But Polestar Zero project is actually taking a responsibility of addressing the emissions that come from the production of a car across the entire life cycle, from sourcing materials to the end of life. If it's going to be recycled, reused, remanufactured, etc. So this is a massive undertaking at both research and the engineering fronts. And actually, it's incredibly rewarding to be part of something so unique.
You are the only car company I met that claims that you are willing to change a material or process in running platform to reduce the CO2. And believe me, I work with 32 car OEMs, and you're the only one. Of course, I'm impressed, but it also makes me a little bit sad.
That's a good point. I mean, when we are thinking about, again, the urgent and effective action, you have to be open to new processes, new materials, and you have to find a way. Sometimes there would be a material which is more expensive, then you have to address the cost in another way, changing the design to use less of resources, and so on and so forth. But when we come back to the Polestar Zero project, to answer your question, I would say that running a project like Polestar Zero requires a completely different approach compared to traditional car development projects.
Yeah, how do you run that and manage such a project? As it's impossible for every other OEM to change something in running series.
Yeah.
And even Tesla, that has a continuous development cycle, is an impossibility for most legacy OEM. And now you go ahead and say, okay, if we change it even more often, if there's a better solution out there. What's the managing part of such a project behind? How it makes a difference in managing such a project?
Yeah, that's a good question. I would say that, first of all, one has to fully digest the need here. It's like you either achieve the full elimination of the emissions or drastic reduction of the emissions from the industry. To have such a culture, to have such a mindset, that you need to find a way. If that's the only possible solution to kind of implement a new technology, to change material, then you have to be ready. You have to kind of prepare the ground. So how we handle the Polestar Zero project, I mean, such an challenging engineering project, I would say that we have 3 subsequent phases, which is directed basic research. It starts from the textbook concepts towards applied science, and then the last step would be product development. It's not about just making a small improvement, I would say. Definitely that is not the case, but it's about to rethink every step of the process, right down to the chemical reactions, that produce man-made greenhouse gas emissions as a product. So consider production of steel, which is an important part of today's electric vehicles or cars, even ICE ones. So, what happens in steel production is that you have a chemical reaction that is happening all the time, that has been happening for centuries. And that is when iron oxide, Fe2O3, is reacting with carbon or coal or metallurgical coke. And these are the reactants of a chemical reaction that gives you pure iron for you to make steel and a lot of CO2. In terms of aluminium production, you have aluminium oxide, and that oxygen reacts with the graphite electrode. What happens? Plastic production, you have cracking of hydrocarbons, heating, CO2, ethylene, So the same thing. Very few chemical reactions that I just mentioned, they are emitting more CO2 to our beautiful sky than the amount of CO2 that all the trees in the whole wide world can absorb per year. These few chemical reactions, thinking about the root cause of the problem we have. And that requires a lot of collaboration, a lot of outside the box thinking, a lot of cross the field interactions, and so on, in order to kind of address those types of chemical reactions that are producing CO2 all the time.
But then it must be a shortcut. Just use recycling. I mean, if you use recycled material, and you go from 20 kilograms of coal-based aluminum, pure aluminum, smelting in China, and you do it with steel aluminum, you're down to below 1. I mean, that must be the thing, and that 1 kilogram comes from the gas burners, basically, when they melt the thing. But what I'm trying to get to, I hear things from car makers that they want to have a gigacasting. It should be 10.5% elongation, 0.03% copper because it might corrode, and it should be 100% sustainable and at the same cost as the scrap-based material they are using as of today. And I mean, you need to negotiate with God to get those elongation numbers. And so you say thank you, but no thank you, and then you walk away. I usually say like this, and see if you agree with me. It will come a time in car making where people need to start to negotiate elongation on big gigacastings. Because the higher the elongation, the more pure material you need to have, the less recycling you will have when it comes to iron, copper, zinc, titanium residues from your recycling. And then you start to you have to negotiate this in one way or another.
I think also to add to that, who is doing the innovation? Is it the engineering team or is it the purchasing department? And I think when you give innovation to the purchasing, you end up what we already have, a 1.5 ton car with a diesel engine, 2 liter displacement, and that's it, because you have everything lined up. It's the cheapest way to do.
Yeah, and you also get a 3% discount from previous year's price list.
Yeah.
Then you take inflation into consideration, 10 years inflation, and then all of a sudden you pay 2% more, actually. But that's another story.
There is no way to stick to the well-established way of working, to have in front of us a table of mechanical requirements and still trying to increase the recycling content or to make any change in terms of manufacturing process, going from a single piece casting to mega casting, as you mentioned. So you need to come out of your comfort zone. This is like the first requirement. Everyone has to come out of their comfort zone in order to be able to address a big problem like this. So sustainability is not just a nice thing to have, but rather a requirement. So you have the requirements currently now is like mechanical properties, which is related to safety, corrosion properties, all other physical properties. And then you have another requirements, which is sustainability, that has to be fulfilled. Not just saying that is a nice to have, let's stick to what we have been doing for years and years. But then you also ask something about recycling. That's a good question. I would say recycling is just one way forward. Imagine if everyone is going to use recycled metals. You cannot find enough recycled feedstock. So what to do next? So you are taking recycled materials from another application that could use that and put it on your products and saying that we have increased recycling content, but we are getting that recycled content from another application and they are lacking the materials. So it's like shifting the problems from one part of society to another. That's why I would say we will forever need virgin materials. And that's why we need to address the core problem of not, ignoring what's happening in production of virgin elements. Another point is that I mean, in the recycling area, I would say that we are still far away from elimination of CO2e. I mean, the whole industry. Imagine that a recycled aluminium, they need to add alloying elements, a lot of silicon. So what's the carbon footprint of silicon?
I know it by heart. 40% up in average from Zorba to do an ADC 12, 2 to 6.
Exactly.
Typical, I mean, that's my livelihood. You're discussing there. That's the only number I can give you, Marco.
Yeah.
40%.
The last one on the recycling topic, and is the, I think, very critical topic of if we are doing really recycling to the material with the same quality, or downcycling material with less value products, or we are towards upcycling. So what is right now happening is that most of the recycling practices are happening in the area of downcycling. Oh. And that is another big problem.
Oh, yeah. It is. I mean, sometimes when I feel a little bit depressed about this, and when I was speaking with the typical automotive company, I speak about CBAM and all this, and they say, yeah, it's super important. So yeah, okay, should we tune into this? Should we discuss this? Should we do a business proposal? But, oh no, that's another department. Okay, there you go. And then I used to think about this big pile of engine blocks. I mean, guys, walk out to ICA here in Sweden or the grocery shop there in Switzerland, look at a parking lot, and see all the ICs that are 8, 10, 12, 15 years old. There's a big pile of silicon 10, 12 around this. Who's going to buy that scrap? I mean, it's useless for everybody. I mean, maybe you can do an ironing iron with it. I don't know. But I mean, that's a crappy material. We're speaking about 1% elongation. Pretty brittle. Crack propagation. Who's going to buy that?
Also, when you look at especially now digging a bit into our foundry spectrum, when you look at the parts that are in the foundry, you have several tiers here. Sure, the top end is the gigacasting, which has structural and long flow length, a lot of production issues. Yeah. But you don't need to start there. There are so many cars that just hold an air compressor or a pump or a distribution box for some electric things. There is no high mechanical properties to that part, but it still has the same specification as everything else, because that makes it easier. I think tiering here would be definitely good to see which thing can have a higher copper content, a higher iron content, to incorporate that, because you don't need the properties that you need for a structural casting that is crash relevant.
When I was at university, I was thinking more about the importance of the chemical composition on the product quality. What if you have 0.1% higher iron and so on? Wow, I was trying hard to show that you have more intermetallics and they are deteriorating your mechanical properties. But then in industry, at some point, I realized that processing itself, what governs the product quality, at least over 90% of the cases. If you have a good control over the process, then it doesn't matter if you have iron content towards the lower end or the higher end, or even more than the specific composition or the range you have, the standard. And then I realized that process could destroy a component quality of a very good feedstock material, and a good process control could give you a quality product from, for example, 100% post-consumer scrap feedstock. So now for me, it's very clear to conclude that there are a lot of opportunities when it comes to the process control, when it comes to openness of the foundry industry to utilize innovative process steps even to eliminate a lot of emission sources.
I agree. I used to say like this: if you look at the theoretical strength of aluminum, it's super high. And that is where we start in the foundry industry. And then we do our utmost to ruin those numbers in every step possible. We introduce oxide. We do bad degasting. We have a lousy temperature control. We have oil in our shot sleeves that we push into the metals. We get these, every step we try to get as low as we can. And in the end, we do a test bar and say, hey, look at this. It's really good. It's like a Natka standard. And then we're happy.
That's the case. Oxide, porosity, shrinkage, pores, in 95% comes from the process. Totally agree.
I can give you a super example. We have done, what is it now, double digit of tools for our carbon dioxide systems. We push them up to 350 bars, right? And we tell every customer this. Please, dear customer, your specifications say 1% elongation and quite a stiff material. Why don't you look at an A380 with some magnesium and a T5? You avoid the T6, you get to a T5, which no blisters, so it will be cheap like crap, and you have a very stiff, super strong material. We're talking about 260 megapascal yield strength. I mean, that's strong. That's really strong. And then you can do 4 millimeters instead of 5 millimeters. But no. Then someone has done the specification with this lovely little porosity scheme, with carbon dioxide porosity requirements doesn't say anything, because what kills your product is actually metal meeting in the casting. We know this by heart. It almost ran us bankrupt once. And they don't listen at all.
No.
They say, oh no, we should have an A350. It should be a virgin material because it has to be very clean, because our metallurgist, Franz Josef, Doctor, has said that. All right. The whole company goes that way. It's only 8 million pieces. I mean, why bother? Yearly.
Yeah. In that case, it's a completely new part spectrum, and then you stick to something that is now 30 years old. It worked at the time. For that product spectrum, it just carry on, and nobody starts, okay, now we have to go back to square one and figure out what we actually need. And especially if you get from a T6 heat treatment to a T5, that's something like cutting 80% of the carbon emissions from the heat treatment out, because you don't have the solutionizing, you don't have the quenching, you get rid of all the deformation in the quenching. But specification said I have to do it, now I do it.
Yeah. And then the porosity spec,
This the tendency to over-engineer components, that is something that is really one can consider as an obstacle towards true sustainability. Totally agree.
It is a great problem. That was why I was talking about this negotiation about the properties that sometimes you have to choose. I mean, everybody says that they need lightweight, and we see the big trend now going from aluminum silicon 10 to aluminum silicon 7 for gigacasting. I mean, we know it by heart. We work with the guys. And the fact is that the only thing that's happening now is that you have to increase the thickness of the part for making a bigger part. And a bigger part means less production cost. But you increase the weight of the car. And if you look at what are you competing against? You're competing against sheet metal. There's no better aluminum material than sheet metal. I mean, it's super defined. It's more defined than Coca-Cola. It is great. I mean, what it is. So and you can do whatever bend you like, and you can do welding and the crack propagation around the rivet. I mean, hey, come on, you're home free. And then you go to die casting, which is probably the worst process ever for getting high numbers out of aluminum. And then you start to find a way to going back to the sheet metal, instead of having this negotiation saying, okay, do we want a 50 kilogram lighter car, less emissions, or do we stick to our 9.8% elongation requirement? I mean, they're painting themselves into corners that will be very painful to get out of, because it will start to cost money.
Yeah, but one question to that. Well, one of the critical things, if you have to build out everything in smaller parts and ship them all around the globe, that's a massive impact on the carbon footprint. Isn't then that the biggest advantage for the gigacasting, that it's really locally, that you don't have these long transport routes?
And now someone has to see what kind of improvements could be done to make large casting or giga castings.
I don't get it. I hear this all the time. Yeah, with one rear floor we take out 70 parts. Yeah, but why not going for 2 parts instead of 1 part? Why do you need? I mean, excuse my language. Isn't this just a very global dick measuring contest right now? Who has the biggest locking force? I mean, you have to build a new road if you have a 20,000 ton locking force machine. It takes I heard something like 16 weeks for the steel to cool down after casting the parts for the machine. I mean,
Yeah.
this is at the Tower of Babylon. It will have setbacks. I strongly think it's the right way to build a car, but I think it's going too fast. I think it will cost a lot of money because people are going in ways that will go the other way, go bad ways.
That's why it's very challenging area. I would say it has a lot of things surrounding, and it requires a collective effort.
Definitely, and also what we've seen from your explanations, we definitely need a lot of brilliant boys and girls in our industry to succeed with sustainability. So what would you recommend your younger self transitioning from university into the car industry? What would be your recommendations or tips for the people that want to go in the industry, that they don't have a culture clash?
They should realize that everything in the science and engineering could be seen from the lens of sustainability. Just to try to understand what is the environmental footprint of this experiment I'm doing. And is there any way to do the same experiment to make the same specimen, but with less environmental footprint? So this is an extra question that could be put in front of every research step you are doing in the university, or even everything you read in a book. That question could bring you an innovative way of thinking. So to do things differently, that is not only towards sustainability, but also it ticks other boxes.
Perfect. I really like that approach, especially with the moonshots. Even if you don't reach the moon of your target, if you get 80% of it,
Exactly.
that's already 1,000 times more everybody else achieved. And I think that's the perfect way to end that podcast. So pick your moonshot, go more sustainable, and thank you for listening. Don't forget to subscribe. Thank you, Marco, for talking to us.
Been a pleasure. Thank you, Marco.
The same. Thank you very much.
And then goodbye, and we see us in the next Gold Nugget.